So we'll have this brief session on trigonometric equations. I will explain the important terms and the steps to solve trigonometric equations and inequalities, right? It's a very simple topic. It requires memorization, so you'll have to memorize the general solutions of of some standard equations, right? That's the most important part of this chapter. That's not it though. You'll have to have some understanding. The understanding part I'll give you, and then after that I'll state the general solutions of the standard equations which are relevant for your syllabus, and you'll have to sit and memorize those 5-6 equations. They're not very difficult to memorize. It just comes. If you solve 10-15 problems based on those equations, you'll be able to remember it, right? But the more important thing is how do you use those equations. So let's first actually look into what trigonometric equations are. So these equations which have one or more than one unknown trigonometric quantities, right? So trigonometric quantities are your sine theta, cos theta, and all the 6 functions that you know, right? So for example, this equation, sine theta is equal to half. There are some values for theta for which this equation will be valid, and this has this unknown trigonometric term sine theta, the value to which you don't know. That's why it's a trigonometric equation. Likewise, sine square theta equal to 3/4. The unknown trigonometric term here is sine square theta. Here you have 2 unknown trigonometric terms, tan power 4 theta and sine square theta, but nevertheless one or more than one unknown trigonometric terms in an equation. In an equation, so you have to have this equal to sign, and this must be equal to something, right? So you already know what an equation means. In a normal equation, if I put some unknown trigonometric terms, that actually becomes a trigonometric equation, right? What do you mean by the solution? So just like every other algebraic equation, even trigonometric equations, the solution means the same. Those values of theta, which satisfy the equation. So if I pick up any of these equations, so for instance, let me pick up this one. Sine theta is equal to half, right? Sine theta is equal to half. Now, what are the thetas that can satisfy this? Theta is equal to 30 degrees. Yes, it can. Then something like a theta is equals to 180 minus 30. Yes, of course, theta equal to 180 minus 30 also. In the second quadrant, sine is positive, and 180 minus 30. It's something like sine 180 minus 30, which is sine 30 itself, right? This is something that we've already seen. So, and sine 30 is half, right? So 180 minus 30 will satisfy this. Likewise, 360 plus 30 also will satisfy this, because you have taken a full rotation and you have gone 30 degrees ahead, so that full rotation is actually nullified in 360. But nevertheless, 360 plus 30, which is your 390, even that will satisfy. So you will have infinite values. You will have infinite values which will satisfy this particular. You can just keep adding 360 through this 30, right? You can just keep adding 360 to this 30, and you'll keep getting values which will satisfy this particular equation. And all those things are called your solutions, right? Now coming to a very important term, principal solution. What do I mean by principal solution? Now, out of all these infinite values, those which lie in 0 to 2 pi, they are called your principal solutions. So you have infinite angles which will satisfy this equation. Now I need only those angles which lie in between 0 to your 360. So those values which lie in this first rotation, that's basically all those values are your principal solutions. So can you actually pick up from all this and tell me what are the principal solutions? Yes, the answer is 30 degrees and 180 minus 30, right, which is your 150 degrees. So because these two angles they are lying between your interval 0 to 2 pi, they are your principal solutions. So I can say that pi by 6, which is 30 degrees, and 5 pi by 6, which is 150 degrees, these two are the principal solutions to this equation. But how many solutions exist? Infinite. How many are principal? Only 2, because only these two lie in this interval 0 to 2 pi. Finally, coming to general solution. General solution is the set of all the solutions. Now, there is not a lot of difference between solution and general solution. They actually mean the same thing. Solution means every value which will satisfy this. General solution is the collection of all those values which will satisfy this, right? So throughout this particular section, throughout this chapter or throughout this module, trigonometric equations, the only goal that we have is the moment we look at a trigonometric equation. So the moment we look at an equation, we have to form the general solution for this equation, right? So we have to form we have to form an equation or we have to form a solution, something like 2n pi plus theta, where n is an integer, right? So as n keeps changing, you'll keep getting different values, and all these values will satisfy this. So my only motive in this chapter is to pick up all these and bring them or write them down as a single expression, which is my general solution. That is all that I have to do as far as trigonometric equations are concerned, right? To do that, you'll first have to memorize the general solutions of various equations. Let's see what are the general solutions of various trigonometric equations. Now, here in front of you are the general solutions of some standard equations. These are the only thing that are relevant as far as your syllabus is concerned. So whenever you get a trigonometric equation, what you have to try to do is, you have to try to simplify that equation to bring it to one of these forms. So you have sin theta equal to sin alpha form, sin cos theta equal to cos alpha form, tan theta equal to tan alpha, and these three. So you have to make sure that the equation that's given to you is solved and reduced and brought to one of these forms, because for these forms you know their general solutions. So the general solution for this sin theta equal to sin alpha is this. So n belongs to integers, so theta equal to n pi plus minus 1 power n into alpha. So if you see sin theta equal to sin alpha, you'll be very tempted to cancel sin and say theta equal to alpha. Fine, theta is equal to alpha. But is theta only equal to alpha? The answer is no. There are so many values, right? Because sin 30 is also half, sin 150 is also half. As I told you, sin 390 is also half. So as you can see, so many values are giving the same output half. So how can I say that only theta will be equal to alpha? There can be so many other values, right? So that is the reason why we have a set of solutions. So all these 30, 150, 390, all of them are, they're brought as a set together, and equations of this form will have general solution like this. So if I keep changing n, if I keep varying it over one, or like if I keep varying n from minus infinity to something like minus 3, minus 2, minus 1, 0, 1, 2, 3, if I keep varying it up to infinity, all these integers of n will keep giving me different values for theta, and all those thetas will satisfy this given equation, right? So that's why it's important to remember that, okay, whenever you see sin theta equal to sin alpha, this is how the general solution will be for that particular equation. For cos theta equal to cos alpha, the general solution or the collection of all those values which satisfy this equation is written in this form. This is the general solution. For tan theta equal to tan alpha, this is the general solution, right? And for these equations, whenever you have squares, sin square theta equal to sin square alpha, cos square theta equal to cos square alpha, and tan square theta equal to tan square alpha, for these you have n pi plus or minus alpha. So to simplify it for you, let me just discuss a very simple question. This will help you understand how to use. So first of all, there's no way you have to memorize these four. You have to memorize these four through problems or through your brute methods of memorizing. I don't really know, but you have to memorize it. So if you have equations like 2 cos square theta plus 3 sin theta equal to 0. For example, this is the question given to you. This is a trigonometric equation, as you can see. 2 cos square theta plus 3 sin theta is equal to 0. Now, these are unknowns, right? Your cos thetas and your sin theta both are unknown. So I can write cos square theta as 2 into 1 minus sin square theta plus 3 sin theta. So now, this trigonometric equation is not in any of these forms, So I have to simplify it to make sure that it comes either in this form or in this form or in this form or in any of this form. So I have to make sure that it comes to one of these forms. So 2 into 1 minus sin square theta plus 3 sin theta is equal to 0 can be written. Then if you rearrange and form a quadratic in sin theta, so what you'll get is 2 sin square theta minus 3 sin theta minus 2 equal to 0. And then, when you take two terms common, you have sin theta minus 2 into 2 sin theta plus 1 is equal to 0. Now as we know, sine theta cannot be equal to 2 because sine theta lies between minus 1 and 1. The maximum limit sine theta can have is 1, so it can't be 2, so this term can't be 0. So that means this term has to be 0, only then the product will be 0. So 2 sine theta plus 1 is equal to 0. So all those thetas which satisfy this equation have to satisfy this equation, right? So now as you can see, sine theta is equal to minus half. Now whenever I have something like this, what I will do is I will take sine theta is equal to sine of minus pi by 6, right? So what I will do is I'll take that value of theta or that value of alpha. So if I see that okay, I can convert this to sine theta equal to sine alpha form. So this is my sine theta equal to sine alpha. I have sine theta equal to something. If that something can be written as sine of something, then it will get converted to sine theta equal to sine alpha form. So indirectly I have brought this to this form, right? So I need to choose that alpha which will satisfy this, right? So usually what we do is when you read inverse trigonometric functions, you will see that the domain of sine inverse x, the domain of cos inverse x, you will also see the domain of tan inverse x. You will also see the ranges, right? So what we try to do is the value that we choose here, we try to make sure that it's in the range of sine inverse x. That is what we try to do. So if you see minus half here, now there can be lots of values which will satisfy minus half, right? You can have minus pi by 6, so sine minus pi by 6 is minus half, or you can have 2 pi minus pi by 6, right? So you can either have 0 minus pi by 6 or you can have 2 pi minus pi by 6, even that will satisfy. But 2 pi minus pi by 6 is not in the range of sine inverse x, so we usually tend to avoid that. We tend to take that value of alpha which is in the range of sine inverse x, right? So if I had something like cos theta equals to cos alpha, so if I'll choose that alpha which is in the range of cos inverse x, right? So that is what we try to do usually. So minus pi by 6 is in the range of sine inverse x. Don't get confused about this. We'll study in inverse trigonometric functions what are the ranges of sine inverse x, cos inverse x, right? So we've chosen a value minus pi by 6. So your alpha can now be replaced with minus pi by 6. So you have sine theta equal to sine pi minus pi by 6, right? Sine theta is equals to sine of minus pi by 6. Now this is of this form. So the general solution is theta is equals to n pi plus minus 1 power n into alpha is minus pi by 6. So this is the set of all solutions, all thetas which will satisfy this starting equation, right? So I hope you have understood what were the steps. You have to simplify this to bring it to one of these forms. I brought it to this form. I choose an alpha which is basically in the range of sine inverse x, and then finally I will use the general solution formula, right? So these boxes, these 4 boxes, these general solution formulas, you have to remember them as it is, only then you'll be able to use them in the examination, right? So this was all about the general solutions of standard equations. Let's look at a few more important concepts in trigonometric equations now. Now it's an interesting section that we're going to see. We're still in trigonometric equations and we are now looking at the solutions of equations of this form: a cos theta plus b sin theta equal to c. Now we've already seen this we've seen this something very similar, a cos theta plus b sin theta plus c, the range of this function, right? So what we tried to do is we tried to take these first two terms and reduce it to sine theta plus alpha form. We will do something very similar here. So this is our equation. What we will do is we'll divide with under root a square plus b square on both sides. We'll assume that the first term is cos alpha, the second term is sine alpha, right? So it will become cos alpha plus cos theta, sine alpha plus sine theta term. We'll assume that this is my cos beta. Now remember, this will be cos beta only when your c is less than under root or less than or equal to under root a square plus b square. Remember, if your c is not less than this, then there will be no solution to this equation. Rather, the complete condition is mod c by under root alpha a square plus b square should be less than 1. This is only a part of the solution. This is the full condition, right? So your mod c should be less than under root a square plus b square. A square plus b square under root is anyways positive, so I can remove the mod. Your mod c should be less than this. Only then solution will exist. Only then solution exists. If your mod c is greater than under root a square plus b square, no, it won't exist, right? It has to be less than or equal to, right? If it's greater than under root a square plus b square, then I won't be able to assume this as cos beta, because cos beta has to be less than 1 or equal to 1, right? Cos beta lies between -1 and 1. So that is the reason why this quantity also should lie between -1 and 1. That means mod of this quantity should be less than 1. That is what the quantity lying between -1 and 1 means, right? So this has to, so before you start solving this form, you first have to check this condition. If this condition holds good, only then you start solving, right? If this condition is violated, if you get mod c greater than under root a square plus b square, then forget, don't need to solve anything, just mark the option that the equation has no given solution, no theta will satisfy this given equation, right? So let us assume that, okay, your condition is satisfied and this is holding good, so this condition is holding good, then it will be cos theta cos alpha plus sin theta sin alpha is equal to cos beta form. So this can be written as cos of a minus b, like theta minus alpha, cos a minus b equal to cos a plus b plus sin a sin b, right? Now this is of the form cos theta is equal to cos alpha. We know the general solution, we have just seen in the previous section, that it's equal to theta is equal to 2n pi plus or minus alpha. So this is my theta minus alpha is equal to 2n pi plus or minus beta. So theta is equal to this, right? This is the general solution. All the thetas, and where your n belongs to z, right? Your n belongs to this n belongs to integers. Now as you keep changing n and as you keep taking plus beta and minus beta, you will get infinite solutions of theta, infinite values of theta. Those thetas will satisfy this given equation, right? There's one more thing that you could do. If you assume this as sin alpha and if you assume this as cos alpha, even then it wouldn't have made a difference. So this would be sin alpha now, right? And this would be your cos alpha. So this is of the form sin a cos b plus cos a sin b, which is sin a plus b now, which is sin a plus b now. And even this you would have to assume sin beta in that case. So if you assume this as sin beta, then these two would be your sin betas, right? So I'm now trying to show you that even if you take it as sine on both sides, then what happens, right? Then now your general solution won't remain the same. Initially you had something else, 2n pi plus or minus something. Now you will have alpha plus theta is equals to n pi plus minus 1 power n into beta, where you will try to make sure that your beta is in the range of sine inverse x, which is basically your minus pi by 2 to pi by 2 that you will see in inverse trigonometric functions. But this is how your general solution will look like. Is this wrong? The answer is no, even this is right. This general solution is also right, and the one that we saw before when we took cos on both sides, that was also right? Both are right answers. So in the question, if they specify that, okay, you have to write in terms of cos, then you have to use that method. If they don't specify anything, both are right? In fact, as you keep giving values to n, the collection of thetas that you get from this and the ones that you get from that are both the same, right? So it won't make a difference. So with this topic done, let's move on to the final thing in trigonometric equations. That's your trigonometric equations inequalities now. So let us finally look at the trigonometric inequations. That means inequalities, things of the form f of x greater than or equal to a, f of x less than or equal to a. So now you don't have equal to, but greater than and less than things also. Like how do you solve such things? So something like, sin x greater than or equal to a, or cos x less than or equal to a, or sin x less than or equal to a. All these things, tan x greater than a, everything, all those trigonometric. This f of x is your trigonometric function. It's less than some value or greater than some value. How do you solve such things? How do you find those x's or those thetas which will satisfy this? So the steps are written here. You will first draw the graph. So remember, you have to know the graphs of all the trigonometric functions, all the 6 functions that we saw. You have to know their graphs, you have to know their domains, you have to know their ranges and their periods. These 4 things, as I told you while introducing those graphs to you, you have to look at them and memorize, right? So draw the graph of f of x in an interval length equal to fundamental period of f of x. So something like, if I'm drawing the graph for sin x, I have to draw it for at least a length equal to fundamental period. That means the fundamental period for sin x is 2 pi, for cos x is also 2 pi, for tan x it's pi, right? For cot x also it's pi. So you have to know the fundamental period of the functions, and you have to draw the graph of length at least that much, at least the fundamental period. Then you will draw the line y equal to a. The line y equal to a is a line that's vertical, that's perpendicular to x-axis. It's perpendicular to y-axis. It's perpendicular to y-axis. So your y equal to a, where this is your a 0 comma a, right? So then you will take that portion of the graph for which the inequation, this inequation or this inequation, whatever is given in your question, you'll take that portion of the graph in which the inequation is satisfied, right? And then finally you will add nt in the solution, n into capital T, and take the union over all the integers. Your n is obviously an integer, right? So you'll add nt, take the union over all integers, where t is your fundamental period of the same function f of x, right? These are the steps. Let me actually explain it to you using a simple question. So I have a question for you. The question here is solve for sin x greater than minus half, right? So this is of the form this f of x greater than or equal to a. So you don't have an equal to, you have greater than a, right? So sin x greater than minus half. Now as per the steps, the first step that you do is draw the graph of f of x. Your f of x is a sin x here. You have to draw the graph of sin x in an interval length equal to the fundamental period. So what I will do is I'll first draw the graph and then see how it goes. So I will draw the graph here. Sin x starts from 0, goes to 1, goes to minus 1, comes to 0 and keeps going, right? Goes to minus 1, goes to 0 and keeps going. So I need to draw the graph for at least this much length, right? At least the fundamental period. The fundamental period for sin x, by the way, is 2 pi. So before actually choosing the interval, what I will do is I'll draw the line y equal to a. My a is minus half here, so the line y equal to a is this line. This is the line y equal to a. So y equal to minus half. This is my line. Now as I can see, this is intersecting this curve in a lot of points. It's intersecting this curve. It's intersecting it here. It's intersecting it here, and it'll just keep on intersecting here. It'll intersect it here also, and just keep on intersecting. So this particular thing, the x coordinate of this intersection is minus pi by 6. The x coordinate of this intersection is pi plus pi by 6, which is 7 pi by 6. And likewise, you have x coordinate here, x coordinate of this. Every point will have its own x coordinate and y coordinate, right? So I'm just writing the x coordinates. Let me actually tell you why I'm doing that. So what I will do is I will choose my interval. I will choose my interval between minus pi by 2 to 3 pi by 2. So the second step, the first step, the second part of the first step, basically the choosing of the interval, I will look at the graph and then I'll choose my interval, so that I'll choose it between minus pi by 2 to 3 pi by 2. As you can see, 3 pi by 2 minus pi by 2, which is length. So if you have a to b, the length is b minus a, right? The length of the interval is b minus a. The length here is 3 pi by 2 minus pi by 2, which is 4 pi by 2, which is 2 pi. So the length is 2 pi, right? The length is 2 pi. You have to just check the solution over this 2 pi interval. So your minus pi by 2 is here. This is your minus pi by 2, and your 3 pi by 2 is here, right? So this is your 2 pi length. This is your 2 pi length. So in this, I will choose that portion. Now I'll forget about the rest of the graph, right? I'll forget about this part. The only thing that I'm concerned is what happens here in this 2 pi length. So in this 2 pi, I'll choose that portion which satisfies this inequality. That is basically my third step. So which is that part? Let me just look at that. So it should be greater than minus half, right? So your minus half is this green line, and the value which is greater than your minus half is this. The part is this. This is greater than minus half. So the minus half line is here. and only this much of your graph is above that. The two pink portions that you see, they are below the line y equal to minus half. So I'll write the the x coordinate, that I'm talking about, the x coordinate has to lie between these two, right? Has to lie between these two. So the x coordinate has to lie between minus pi by 6 and pi by 6. Obviously it can't be equal, right? It can't be equal because equality is not there, right? Equality is not there, so it can't be equal. So minus pi by 6 to 7 pi by 6. So what does this x coordinate say? That okay, if my x coordinate is between these two, then my points, the corresponding y coordinate basically, or basically the point finally will lie on this portion, and this portion is greater than minus half, right? So my x has to be in between these two, and the final step what I have to do is to generalize what I have to do. I have to basically add n into capital T, where T is the time, where T is the fundamental period. The fundamental period for sin x is 2 pi. So 2 pi into n into 2 pi, which is 2n pi. So I have to add 2n pi on both sides. So 2n pi minus pi by 6 less than x less than 2n pi plus 7 pi by 6. This itself means now my n belongs to integers, right? N belongs to z, basically integers. So all those n's I will keep putting, and I'll take the union of everything, and that will form my general solution. So this is the final answer. This is the final answer to this question. Sin x greater than minus half, your x has to be satisfying this particular quantity. So these are the steps. This is how you actually write the general solution for inequalities in trigonometric equations. So with this, we complete this topic, trigonometric equations. Let's move on to the more involving topic, inverse trigonometric functions now.